Hello and welcome to the very first video from Further 101. My name is Jake and I'll be running you through this video on types of variables, which is the very first installment in the core module series Data Analysis and Financial Modelling. But before we jump into that, we'll spend some time scoping over what this whole topic is all about and why it's useful, as well as defining what data actually is. If you wish to skip to the main content about the types of variables, click on the timestamp in the description below. If you weren't sure already, the whole core module is essentially a brief introduction into statistics and how they can be used to provide information to us. Throughout this module, you will be provided collected data and advised to organise and display this information with at least one of two goals in mind. The first is to analyse the data and draw conclusions about what is happening in the world. The second is to make predictions about what could happen in the future given what has happened in the past. Now you might think that only the government and university researchers would collect data for analysis, but statistics is used in all walks of life, particularly as computers have become even more powerful. Companies collect data to find out more about their products and consumers, and even us as everyday persons collect and analyse data without even realising, such as when we choose which product to buy at the supermarket, or we track our fitness progress on an app. Try to keep these goals in mind at all times as you progress through this module. Now, before we even define the types of data, we need to ask, what exactly is data? Data is just a piece of information that has been measured, recorded, or observed. Take a look at the following table of information. Each separate recording of information is considered an individual piece of data. Collectively, this table can be called a data set and would have been gathered with some common purpose or goal in mind. Notice how the data has been neatly organised into rows and labelled columns. The labels that organise data of a similar nature together are known as variables. Here we have 4 variables denoted in the columns: height, weight, the number of pets owned, and the colour of a person's car. You will also notice that some variables, like height, have data with numbers, and some variables have data with letters or words, like colour. This segues nicely into the main topic of this video, different variable types. Data and its respective variables can be broadly defined as one of two types. Categorical variables contain data that describes the quality or characteristics of the thing being recorded. The data is typically presented in word format, although there are the odd exceptions that we will explore soon. Some examples of categorical variables include the colours of cars passing by, the gender of a person, or the town that a person lives in. Numerical variables contain data that describes the quantity of what is being measured or observed. Classic examples of numerical variables are a person's height or the number of siblings a person has. In other words, categorical data is used to organise or label something of interest, whilst numerical data indicates the value of something of interest. Each of these broad variable types can be defined more specifically. Let's take a look at the 2 specific types of categorical variables first. If the different data values inside a categorical variable have an implied or logical order of presentation, it is described as an ordinal variable. Notice the name of this type of categorical variable sounds like the word order. This should help to remember its definition. An example I'm sure everyone will have experienced is being asked an annoying survey question that requires you to pick one of strongly disagree, disagree, neither agree or nor disagree, agree, or strongly agree to the question being asked. Notice how it always seems logical to present strongly disagree first and strongly agree last, or vice versa, with the other answers ordered accordingly in between. The data should be presented in this order to make analysis easier and clearer. Another ordinal variable example may be to describe a student's motivation to study as low, medium, or high in that order. If data is categorical, but there does not appear to be a logical order to the data, the variable is defined as a nominal variable. The previous examples provided for categorical variables above were all nominal. Do note that in the past it has not been necessary to specify categorical variables without a logical order as nominal, and simply calling them categorical was fine. Keep that in mind when answering questions asking you to describe the type of variable. Similarly, there are also two subtypes of numerical variables with clear distinctions. If the numerical data is typically collected by counting how much there is of something, the variable is defined as discrete. A clear example is the number of siblings in a family. This data is usually obvious as the numbers are almost always whole numbers, although there are the odd exceptions. If the numerical data is typically collected by measuring the value, the variable is defined as a continuous variable. Some examples include a person's height or weight, or their lap time in a swimming carnival. Now, I did mention before that numerical data can sometimes be presented as a categorical variable. This typically happens if the numerical data is organized into groups. Each group is defined for a specified range of values. For example, a person's height as a variable may be organized according to the following three ordinal categories: below 140 centimeters, 140 centimeters to 180 centimeters, and above 180 centimeters. Alternatively, a more general label may be used for each group without specifying what range of values would fit into each group. For example, a person's weight may be described as underweight, normal, or overweight without any indication of what weight values fits into each group. The key is not to assume a variable type just by reading the variable's name, but to actually look at the data provided or the explanation of the variable provided. Now that we have an understanding of the theory, let's put our knowledge to the test and have a look at a few variables. Have a go at defining each variable by their general type and their subtype. I'd encourage everyone to pause the video, write down your answers, and then hit play again. So, let's go through each of the variables. Of course, a person's town of residence isn't a number, but a name that labels a location. So clearly this is a categorical variable. And there is no logical order that always makes sense to organise the different towns. Some students may argue that you would always put them in alphabetical order, but it might make more sense to order them according to population size, or by the number of respondents from each town. Clearly, there is no one order of towns that always makes sense to present them, so the categorical subtype is nominal. What about a person's BMI score, or body mass index score? Well, technically this is calculated, but it is calculated from two measurements, a person's height and a person's weight. So this variable would be a numerical continuous variable. What if each data value was not a person's BMI score, but a person's BMI label, one of underweight, normal weight, overweight, or obese? Put your thoughts on this in the comments below and compare with other students' responses. Let's move on to the number of cars owned. How many cars a person owns is clearly numerical, and because we count rather than measure the number of cars owned, this variable would be discrete. What about a person's SAC grade in further mathematics? Notice that the description has group scores in terms of grade letters, A, B, C, D, and fail, rather than as individual percentage scores. This is one of those tricky variables where a typically numerical variable is reworked as a categorical variable. Also notice that it always makes sense to present these grade letters from A to fail, or vice versa. So this would be considered a categorical ordinal variable. How about a person's postcode? Well, this is a collection of numbers, so surely this is a numerical variable, right? Actually, we would not consider it numerical, as a person's postcode is neither counted nor measured. That is, a postcode does not provide any value. Rather, a postcode is used as a label for its respective town, so it is actually a categorical variable. Like the town of residence variable from earlier, there is no right way to order the postcodes that can be inherently determined from the postcodes themselves. We can put these in any order we like without too much fuss. So this would be a categorical nominal variable, or just categorical. Moving on to the final variable, shoe size, and I'm sure we have all played around with those funny devices used to measure our shoe size at the local shoe store. It should be pretty obvious that a person's shoe size is a numerical continuous variable. Thank you so much for tuning in to Further 101's first installment in the core module series. If you've got any suggestions for topics to cover in our next videos, chuck them in the comments section below. Don't forget to like this video if it helped you, and subscribe to our channel, as well as head over to our Facebook page. That's all from Further 101.